All right, so I want to cover a little bit of stuff with pointers, but probably you can use a little review on how to create a Visual Studio project. Now, some of this stuff with the project is in the other video recording, but you know, having two things of the same in different places can never hurt, right? I'm not sure how many of you have used Visual Studio before. In 1311, did you use Visual Studio or a different editor?
I used Dev. Yeah,
Dev. Okay. So you know, different people have used some different things. I'm going to base what we're doing on Visual Studio. I mean, I prefer for you to do your projects in Visual Studio. That'll just make it easier for me to grade your work, because I'll ask you to just give me the entire Visual Studio project. But if you're absolutely adamant about using your own different software, that's fine. If you don't have Visual Studio, you can get the free community download. It doesn't cost anything and it doesn't expire. So if you can go to the syllabus, you can find how to download that. Okay. So what I like to do to create a new project, when I'm in Visual Studio, I'll go to New Project, and there's all sorts of different ways you can create projects. There's all sorts of, you know, Visual Studio is an immense program and it can do all sorts of different things, much more advanced than what we're doing. So what I recommend you do is create a simple Win32 console application, okay? And you need to choose what directory you want it in. I'm going to go ahead and have it in this one because I've already created one there before. So you select what folder, and then you're going to select what the name of your project is. And I'm going to name mine Pointers because I want to go over some things having to do with pointers in C++. So then I go ahead and click on OK. And then rather than finish, what I like to do is I like to go to Next and make it be an empty project. Because if you don't make it an empty project, it'll add some source files and some header files, some fancy bells and whistles and stuff that we don't need to worry about in this class. So I like to make it empty and then just make it bare bones, build it from scratch. So now you see you've got your project open, but there's no source files. There's no code associated with this project when you create it as empty. So you need to go to Project, Add New Item, and in this case we're going to create a source file, okay, a CPP file. We'll talk about header files later in the class. And you can give it whatever name, but often I just go ahead and accept the default and I put my main function in my source file. So of course it ends up being blank here, okay? And I always start off my projects by having include IO stream, okay? And that allows us to do cout, cin, all those sort of basic things with having to do with input and output. Then we also need to do using namespace standard. And again, this is one of those things that is you just always do, and we need to do this again because C++ has so much functionality. You can overload everything. You can create your own functions. You can make cout do something totally different. All of the built-in functions that you use in C++, you could give them a completely different meaning and do different things and create your own namespace. But we want to use all the standard implementations of all of these functions, so that's why we need to do using namespace standard. Okay? Then we're going to have every program needs to have a main function, which is it has to be an integer return type, but the main function is never really called, so you can return anything. I just usually have it just return 0. But since it does have a return type, it has to return something. Okay? And then of course the old classic first program is to do hello world. Okay? And then usually I do Control F5 and that will run it. It'll open a console window and it says control hello world. So we've got our first program. Okay? So that's the process of creating a project and getting it set up to be able to do something. Okay? So what I want to do is talk a little bit about pointers and memory locations and regular old variables. So let's say we have a regular old variable I, and we declare that as an integer, okay? And then I can say I want to set I equal to 5, and I want to say, put cout I equals, and then print out I. Nice, good old simple program. Control F5. Boom. I is equal to 5. No big deal. We created this integer. Really simple. Okay? Now, when you create that integer, by doing this line int I, what it does is it looks into memory and tries to find a place in memory where it can store a variable that requires the amount of space that an integer takes up. Okay, an integer takes up a certain number of bytes in memory, and it needs to go find that number of bytes somewhere, of consecutive bytes in memory, to store it. So that's what the int I does. It tells the computer, hey, I've got this variable, I want to store an integer in it, you need to find me somewhere to store this variable. That's what the int I does. Okay? And what I'm going to show you here is I'm going to put a breakpoint. How many of you guys have done breakpoints when you did C++? Raise them high. 2 people. So the rest of you have never seen a breakpoint in C++. Correct?
Correct.
Boy, that's sad. I'm sorry. This is one of the most important ways of debugging your program to find out what's wrong with your program or what's going on. Okay? And so what I'm going to do is I'm going to click on line 6 and put that little red dot. And what that means is when I hit local Windows debugger or go under debug start debugging, which is F5, okay, the program is going to run and it's going to stop at that point in the program. So you see I've got this little arrow here. That means I'm stopped at line 6. I have not yet executed line 6. I've executed every other line of the program up till then. Okay? And down here you can watch things in your program. So there's nothing in the watch. It starts off at empty, but you can choose locals, which will display all of the local variables. And in this case, I only have one local variable called I. It's an integer you can see here, okay? And the value stored in I is some gobbledygook, okay? So when I did line 5, int I told the computer, go find me memory that's not being used for anything else, and allocate that, identify that area of memory to store my integer I. Now, that memory location is not being used for anything right now, but there happens to be stuff in it. Okay? And that stuff happens to be this strange -85 million number. Okay? That's sort of like if you were to buy a new house and you say, all right, I'm allocating that place for my new house. Okay? Go make that house mine, and you go and you pay for all that money for the house and make your loan, okay? Then you move into the house and you go and look in your mailbox, and there's some mail in your mailbox. It's not for you, it's for whoever lived there before, but they don't live there anymore. They got evicted or they got foreclosed on or they're gone. You live there now, but their junk is in your mailbox, and it's not until you start living there and you start getting mail delivered that something of yours is going to get put in the mailbox. And that's what line 5 does, what line 6 does, is it now goes and has the mailman deliver something and put my stuff in my mailbox. So I'm going to click this button here, which is step over. Now, eventually we'll talk about the difference between step into and step over, but here I think it would probably do the same thing either way. So step over is going to execute that command. And now you see 5 is now stored in my mailbox. So not only do I live at that place, but there's my stuff in my mailbox. Okay? And now when I do step over again, it will do cout here and put the I equals 5 in the window. Okay? Now, then I can hit continue, and that will just finish the program and end. Okay? So what we saw there was stepping through the program, we saw how I first got initialized to some jump value, then we put in our value, and then we moved on our merry way. Okay? Now, some of you may have seen the when you pass by reference. Anybody recognize those terms, pass by reference, when you have functions? Okay? And if you remember anymore, you'll remember the ampersand, right? Okay? And when you pass by reference, it doesn't send the value 5, but it sends where to find the value 5. It sends the address rather than the actual value. Okay? And we can get that, okay, by using the ampersand. Okay, so if I use ampersand I, okay, ampersand I is not the value 5, but rather the address where you can find that 5. So if I'm just going to go ahead and hit Control 5 this time, okay, so it says I is equal to 5, which is stored at memory location blah, 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 blah. Okay, that's hexadecimal for the memory location where it's stored. Okay, so again, so that's sort of like, you know, I live at 251 Pickett's Trace. Okay, so if I tell you I live at 251 Pickett's Trace, you'll know where to find my mailbox, but you won't know what's inside my mailbox. Okay, if I say I've got a letter from the IRS in my mailbox, okay, then you know what's inside. But there's a difference between the address where to find the mailbox and the contents of the mailbox. Okay? So I'm going to go ahead and start the debugger. Okay? I've got my int I. Now what I'm going to do is I'm going to go to the watch, and I'm going to type in ampersand I. Okay? And ampersand y, it's going to evaluate that expression, and ampersand I is 3AFD28. Okay? That happens to be the memory location that it got this time. It happened to find that memory location. Now, it also puts in braces here what the actual value is. That's the value that's stored there, but this is the address of I, and that's the value of I. Okay? Now, when I do a single step here, what you're going to see is that the value gets changed, but the address doesn't. Every day, different things get put in my mailbox, but my address on the side of the mailbox is still 251 Pickett's Trace. Okay? Now, what I'm going to do is I'm going to create a new variable k. Okay? And I'm going to say k is equal to I. Okay? Now, one very important thing, just in general, has nothing to do with pointers, is that that equal sign is not a mathematical equal sign. Okay? So sometimes that equal sign makes sense when you think about it as what you do in math. But if you're really thinking like a computer, what that symbol is what's called the assignment operator. And what it does is it says, take the thing on the right-hand side of the equal sign, evaluate that expression, get the result, get the value, and store that value in the variable name on the left-hand side. Store it in the mailbox associated with the left-hand side of the equal sign. Okay? So that's going to take the contents of the mailbox I, copy that content, and put it inside the mailbox that K represents. Okay? So I'm going to go down here, and just like I did a cout for I, I'm going to do a cout for K. K, the value of K, and the place that it is stored. Okay, and I'm going to hit Control F5 and run that. Okay, so I is equal to 5. It's stored at this memory location. K k is also equal to 5, but it is stored at a different memory location. Hey, that's my next door neighbor. Okay, so now me and my next door neighbor both have that dang letter from the IRS in our mailboxes. Okay, but they are different mailboxes. Okay, now I will get my code back, and I am now going to create a pointer to an integer. Okay, now I'm going to go ahead and put a breakpoint here, and I'm going to run it with the debugger. And let's have a look and see, what is this weird J thing? Okay, J. Okay, it's unable to read memory. It's a mailbox that's some bunch of C's. It doesn't even know what it is. It's sort of like I created a mailbox, but it's like on the moon or somewhere under the bottom of the ocean. I said, hey, I have this thing. I want it to point somewhere, but it's not pointing anywhere. Okay, and there's certainly no content. Okay, it doesn't even know it. It's not able to read that memory. Okay, so what J is not where you store an integer, but where you store an address to find an integer. Okay, so I'm going to go ahead and hit stop here and get rid of my breakpoint. And I'm going to say here, let's say I do J is equal to I. And if I try to run that, I think I will get an error. Indeed. Okay, I get an error. A value of type int cannot be assigned to an entity of type int star. Okay, so what I tried to do is I tried to take the contents of the mailbox and make mailbox J, make the mailbox itself be the letter. A mailbox can't be a letter can't be a mailbox. I can put letters inside mailboxes, but I can't make a mailbox. I can't take a mailbox and replace it with a letter. That doesn't make sense. It doesn't make sense to the computer either. Okay? I can store in J an address where you find an integer. I can't store an integer there. So what I can do is I can store the address where I find integer I. Okay? So let me do this now. I'll put a breakpoint here, and I'll start my debugger. This will compile and run. And I look at my locals. Here's I. It's got some gobbledygook value. And here's J. Okay? Now look, J happens to be the same thing as the reference, the address of I. Look at that. J is the same thing. J is pointing to the same mailbox. J is the same mailbox as I's mailbox. And both of them happen to have nothing. They have the junk in it from the old inhabitants of that address. Now, this is really interesting. The next line is going to set the value of I. It's going to take 5 and put it inside of I's mailbox. That automatically also makes J's value be 5 because J and I are pointing to the same thing. They are both 251 Pickett's trace. And if I put a letter inside the mailbox for 251 Pickett's trace, both I and J have the same contents. So this is really interesting. I've been able to update two variables at the same time. Okay? Now, I'm going to go ahead and stop this, and I'm going to get rid of the breakpoint. Okay? And I'm going to go ahead and put my J in here. Okay? Now, the tricky part of this is that J is not a value. J is an address. Okay? So if I type J, that's going to be the address. And if I want the contents of the mailbox, I have to use this asterisk symbol. The asterisk J says, go to the memory location stored in J and the asterisk says get the thing out that's stored there. It's sort of the opposite of ampersand I. Ampersand says go to where the thing I is stored and get its address, return its address. The ampersand returns the address given a variable. Here, it returns the variable's value given the address. It does the opposite. Okay, so when I run this, I now get, okay, I has a value of 5, and it's stored at CFD 70. J also has a value of 5, and it's at the same place. I and J are, for all intents and purposes, the same exact thing. It's the same value, and it's the same memory location. Whereas K is the same value, but a different place. Okay? Now, I got K by storing I in it. If I later then say K is equal to 6 and run that, okay? At first, K gets the value of 5 because it copies what is an I into K. But then it takes 6, and so now 6 is in there. Okay? So K and I are separate mailboxes. And I can put things separately in them, but I and J are the same mailbox. And if I put one thing in one of them, it's the same thing in the other. Okay? Now, you probably got through most of your CSE 1311 not having to worry about this. The closest you needed to come is to pass things by value. Pass things by reference. And the main reason you had to pass by reference is so that you could return more than one thing from your function. That's probably the reason you did pass by reference. Am I right? Okay? Which is a big limitation of C++. Both MATLAB and Python will allow you to return multiple things without having to mess around with values and references. Okay? Now, the reason I bring this up is because the lecture that we would have had earlier today would have talked about dynamic array allocation. And dynamic array allocation requires understanding some of these things about pointers. And I'm pretty sure most of you didn't get this type of thing when you did CSE 1311. How many of you, did any of you in here learn something remotely related to what I just did in 1311? Some of you did. Most of you did not, right? Okay? So actually, this whole thing about pointers is what really sets C++ apart from many other languages. It makes it more complicated to deal with, but very, very powerful. You can do so many things with pointers if you're a really good programmer that you can't with other ways. Much faster and better. Okay, so it's nice to have, but it's a little bit annoying because it's a little tricky and hard to understand. Okay, so that's sort of a baseline introduction to pointers. And when you go and watch that video for the dynamic array allocation, you'll have a little bit of an idea about what I'm talking about. Okay, so let me go ahead.